Welcome to this next video on area. Now, for our learning goal, it's still the same kind of thing. We're going to be using formulas for the area and perimeter of rectangles and calculate volumes of rectangular prisms. We're also going to be looking at squares and triangles too, okay? Which for some of you might be new as well. All right, so at the end of this, you'll want to be able to calculate the area of some simple quadrilaterals and calculate the area of triangles. All right. Oh yeah, the second dimension. So we just did the first dimension, now we're about to move into the second. Okay, so let's quickly grab our little Cartesian plane here, okay? Our X and our Y. Now remember we went from 0 to 2 dimensions, okay? Our points P and Q, remember, in the last video. Now, if we get this length and multiply it by some other length up here, we get that line repeated, and you can kind of see that now we've got an area, okay? So that's our 2 dimensions. So we've got a length going this way and a length going that way now, okay? And that's how we get these areas. And this is something called an array, okay? So you can kind of see where we get our word area from anyway. And something quickly that with this key ideas down here, so when we multiply 2 lengths, an area of space is created as I've just shown here, but an area is measured in something called square units. And just quickly, although you won't be asked to do it this year, but kilometers, meters, centimeters, millimeters, that little ladder that we had, and it was 1,000, 100, 10. So when we're changing between all these, we still use the same kind of idea as multiplying when moving down, dividing when moving up, but instead this time of just dividing by 1,000, say, for meters into kilometers, we divide by 1,000 squared, okay, because we've got square units now. It's just a little trick. You don't really have to do that this year, but I want you to be aware that that dimension ladder thing is something that can be used in a lot of different circumstances. Okay, so it's important in area you remember that we've got these new things now, square units. So centimeters squared, meters squared, kilometers squared. So you can say square meters, square centimeters, square kilometers if you want. Doesn't really matter as long as you write it correctly. Okay. All right, here's the different shapes. So a square is a quadrilateral with 4 equal sides that have right angles. Okay, so the lines mean 4 equal sides. Here we have a side length, usually what we're given, and the formula for this. So the area of a square, I like to just draw the little thing down there for myself. Area of a square is side times side, or you can write it as the area of a square is equal to side squared. Okay, either one of those formulas is fine. All right, a rectangle has 2 pairs of equal sides, so equal, 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 and they're at right angles to each other as well. Okay, and our formula for that is the area of a rectangle is equal to length times width. Okay, so whatever the length is times whatever the width. It doesn't really matter which is which, just multiply them together. All right, a triangle is just some 3-sided polygon. Okay, and triangle, by the way, is about the angles, so it's got 3 angles inside of it. It's not necessarily about the sides, but it's okay. Now, something I want you to think about is that a triangle is totally like half of a rectangle. And it turns out that a triangle is equal to half of the rectangle that encloses it. Okay, so remember that the area of a rectangle was length times width. Okay, and so if we had, this is a right angled triangle, if we called this length the base, okay, that's down the bottom, we're going to call this the height of the triangle, okay? All right, now the height and the base measurement are always at right angles to each other. That's really important, okay? And so because it's half of the rectangle that encloses it, that big rectangle would have an area of just height times base. So the area of our triangle is equal to half base times. Now, I like to write that there. You don't always have to write it, but that means perpendicular height. So half of the base times the height that's at a right angle to the base, because that's really important. All right. Now, if you saw a triangle like this, sometimes the base will still probably be this one here, okay, down the bottom, but the height will usually be given to you as this inside piece here. Okay, so you just get all you need to know. Just check that whether it's a right angle to the base, and that's how you roll with it. Okay, this one here will probably be given as this piece here being the base, and then you might be told that this here is the height, and it's still at a right angle to that. Okay, so you got to be very careful with the way that you use your choose your height and your base for your triangles. Okay, because otherwise it can kind of all go pear-shaped. All right, a parallelogram is a quadrilateral with opposite sides equal and parallel to each other. Okay, so these double arrows there mean that it's parallel, and they're also the same lengths as the opposite. Okay, so single arrow, that means these two sides are parallel and the top ones are parallel. Okay, all right, now to think about the area for this, I want you to think if we just chopped here and moved this over there, what have we got? We've got ourselves a rectangle that has height here, it's at a right angle, and the whole thing is this base length. Okay, so our area of a parallelogram is equal to base times perpendicular height. Okay, so there's your main formulas you need to remember for area this term. I showed you how we come about them because I think it's very important that you understand how it all kind of works. However, you can, if you want to, just memorize them. So it's up to you, okay? But I wanted to show you how we get there just in case you have a bit of a forgetfulness. All right. Let's calculate the area of the following polygons. So we've got here a rectangle, looks like a square, but it's not. And that's a very important one for this term with measurement in geometry. It has to be shown to you to be the case, okay? Don't just assume something's a certain measurement or a certain angle because it looks like it, okay? You have to be sure, and it has to say that it is, okay? So our first one here is a rectangle. So we're going to say that the area of this rectangle is equal to length times width. Remember, we state our formula first. So I'm going to use length as 8.7 millimeters times 10. So that is 870 millimeters squared. Okay, that's super important. You've got to tell me these new units, okay? And it's squared because it's area now, okay? All right, our next one here. So here's a sort of lopsided kind of rectangle. So we've got the area of this rectangle is equal to length times width. See, I'm stating my formula. And I'm going to go 4.5 as my length times 2, which is 9 centimeters squared. Okay. All right, we've got ourselves a parallelogram now. So remember, all that matters is that the two lengths are at right angles to each other. So it's shown here that it's a right angle, and I've got 14 as the height part and 25 as this base piece here. Okay, so there's my base, here's my height. So I'm going to go area of parallelogram is equal to base times perpendicular height, which is 25 times 14, which is 350 millimeters squared. Okay. All right. Aha. So some triangles. So I'm told that this is 22 and this is 8. That's the right angle there. So this is going to be my base. This is going to be my height here. So area of my triangle is what it looks like. Area of area. Area of triangle is half base times perpendicular height. So I have half base of 22, half times 22 times perpendicular height of 8, which is 88 millimeters squared. Okay. All right. Now this one here is deliberately a kind of tricky one. So it's a triangle again, but we've got 3 measurements. Which ones are we going to use? Remember, the key is where is the right angle at? So our right angle is here. Okay. So that means that this length here is going to be my base, and this length here is going to be my height. Okay, it's all about where that right angle is. This one here doesn't even matter. Okay, it's kind of there to trick you a little bit, just to check that you understand how it all works. Okay, so area of a triangle is equal to half base times perpendicular height, which is half times 12.1 times 5.6, which is 12.1 times 5.6, 33.88 centimeters squared. Okay, all right, one last one, a sort of an extension level thing, but you will probably want to have a go at this sort of thing. So what do we do when there's a sort of a weird shape? We don't know the equation, so the formula for the area of a house shape. So what we're going to do is, it's nicely divided here for us. We're going to call this area 1 and this piece area 2. We could break it up into little bits and pieces, working them out separately. Okay, so first let's work out area 2. So area 2 is a rectangle, so it's going to be length times width. And that is 21.5 times 10, which is 215 centimeters squared. Okay, now this top piece, this triangle here, it has a base of 21.5, but its height we don't know yet. This whole thing's 16.2, take away the 10, and we are left with 6.2 as our height, okay, as our perpendicular height. So area 1 is equal to half base times perpendicular height, which is equal to half of 21.5 times 6.2, which is equal to half 21.5 times 6.2 is 66.65 centimeters squared. Therefore, total area is area 1 plus area 2, which is equal to 215 plus 66.65, which is 281.65 centimeters squared. Okay, long video, sorry. Wanted to show you lots of examples so you sort of know exactly how to go about it. All right, thank you so much for watching, and please, if you're having any issues, come see me straight away.